Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss new concept, new chapter, that is permutations and combinations. In this chapter, we are going to discuss the concepts of exercise 7.1. Okay, my children, are you ready to listen the class? Right. Come to the first point. Fundamental principle of counting. What is meant by fundamental principle of counting? There are two types of fundamental principles. They are first one principle of addition and the second one is principle of multiplication. How many types of fundamental principles of counting? Two types of fundamentals of principles of counting. First one is principle of addition and principle of multiplication. In which context we use this concept and in which case we use this concept. Let us take some examples to understand this point clear. Okay, my children. Suppose let us consider this is a room. A person is standing, a person inside the room, a person is there inside that classroom. Here doors, here three doors are there, left side two doors and the right side three doors to exit, to come out of the room. In how many ways this person can out of the room? Yes, five ways. Five ways, because here he may come from these two rooms or either from these three rooms, isn't it or not, my children? Here he has two chances. He may come out from left side rooms or he may come out from the right side rooms. Two chances. Okay, my children. So this one can be done in two ways. If if he wants to come out of the room from right side, how many doors are there? Three ways, three rooms, three doors. Total five ways. So in five ways he can come out of the room. What is the operation we have done here? Plus addition. So in this case, here there are two events, two jobs are there involved, two jobs are involved in this operation. What is that two jobs? What are the two events? Moving left side is one event and moving right side is another event. If he moves towards left side, there are two ways, or if he moves towards right side, that is another event. This can be done three ways. He can come out of this room in three ways. So these in these two events, either this event or this event can be done, isn't it or not, my children? Yes or no? He cannot do at a time left side and right side. He cannot come out of the room from left and right at a time, either from left side rooms or from right side doors. He can out of the classroom, isn't it or not, my children? So in how many ways this person come out of this room? So total five ways. Okay, my children, understood? This is fundamental principle of addition. Okay, my children, understood this concept? Right. In the previous example, we used the concept of principle of addition. We counted in how many ways that work can be done. In how many ways that person can come out of the room? Five ways. We have counted. Okay, my children. Now let us take another example. Here, Suppose this is a room. Here two doors are there, A, B. Here three doors are there, namely 1, 2, 3. Okay, my children. Now a person is standing here. A person is standing here. He wants to enter the room and he wants to come out of the room. Okay, my children. Here, if you observe the question, if you observe the example, there are two events. There are two jobs are involved. What are the two jobs? The person entering into the room, and from that place he has to come out of the room. Isn't it or not, my children? Two events. Okay, my children. So enter and exit. In how many ways this person can enter the room? Either from this door A or from this door B. Isn't it or not? This person is standing this side here in this place. So he can enter this room either from this room door A or from this door B. So two ways, in two ways he can enter the room. Yes or no, my dear children? Right. After entering the room, that event is done. That event is over. Then second event, the what is the second job? He has to come out of the room. He not from this side. Again, he has to come that side only. So, in how many ways he can come out of the room? Either from this door 1 or from this door 2 or from this door 3. In how many ways he can out of the room from this side? Three ways. These are entrance, these are exit. Okay, my dear children. So, finally, in how many ways he can done? He can do these jobs, two jobs, enter the room and exit the room. In how many ways he can do this one? 6 ways, not 5 ways. Don't be confused here, my dear children. I will write in how many ways. Suppose he entered the room through door A. Okay, my dear children. And he exit from door 1. Or he can enter the room door A and he exit the from the door 2, or he enter from the door A and he exit from the door 3. Yes or no, my children? Similarly, he can enter from the door B and he can exit from the door 1, or he can enter from the door B and he can exit from the door 2, or he can enter the door from the door B and he can exit from the door 3. So count how many ways he can done these jobs. 1, 2, 3, 4, 5, 6. So 6 ways. Okay, my children. How can you find principle of multiplication? What is the operation done here? To count the number of ways can be done by this person. Multiplication. So in this case, if you observe this operation, there are two operations are involved, two events are involved. Enter the room and exit the room. Two events are involved. Okay, my children. The first event can be done in 2 ways, and the second event, exit the room, it can done in 3 ways. So finally, in how many ways it can do these two jobs, one after the another? Isn't it or not, my children? Yes or no? One job is over. After that job is over, he has to complete the second job. He has to complete the second event. So two events are involved in this entire operation. Two events are involved. First event is enter the room and the second event is exit the room. Two events, one after the another, consecutively, one after the another. One job is completed, after that second job is done. Okay, my dear, in this case, in this context, to find the number of ways to complete that entire job, we use the principle of multiplication. Understood this example, my dear children? Right. So by the examples, I hope you understood the principle of addition and the principle of multiplication. Now let us write the notes. What is meant by fundamental principle of addition? If there are two jobs such that they can be performed independently in m and n ways. In the previous example, 3 ways and 2 ways. Okay, my children, respectively, then either of the two jobs can be performed in m plus n ways. In the first example, understood that point? Example, my children, 5 ways we have counted. So the total number of ways the two jobs can be performed, either one of the jobs, either of the jobs can be performed, either exit from left side or from right side, any one of the jobs, either of the two jobs, m plus n ways. This principle can be extended to any finite number of jobs. Sometimes we use these words also, events or operations, events or operations as stated below. Okay, my children, in the example we have taken only two types of jobs, two types of events, either from left side or right side, exit from left side rooms or exit from right side rooms. Two events only have taken. Okay, my children, now we extend the same concept to some finite number of operations. If there are n jobs or n events or n operations, namely J1, J2 and so on Jn, n operations are there or n events are there or n jobs are there such that J1 can be performed or J1 can be done. The first job can be done independently in mi ways. I is equal to 1, 2, 3, 4 and so on n ways. Okay, my children. Then the total number of ways in which all the jobs can be done in m1 plus m2 plus and so on plus mn. We add all the number of ways the jobs can be done. In this case, in this context, we use the fundamental principle of addition. Okay, my children, either of any one of the jobs. Okay, my children, understood this concept? Right. Now come to the second fundamental principle, that is fundamental principle of multiplication. If there are two jobs, or if there are two events, or if there are two operations, such that one of them can be performed or can be done in m ways, and when it has completed in any one of these m ways, second job or second event or second operation can be performed or can be done or can be completed in n ways. Then the two jobs can be completed in m into n ways. Okay, my children, in the previous example, the number of ways a person can exit from left, from enter the room and exit the room. Two operations are there. Enter the room is one job and exit the room is second job. Enter the room can be done in two ways and exit the room in 3 ways. So total number of ways he can enter the room and exit the room can be done in 6 ways. Isn't it or not, my children? Right. So in that context, we used the principle of multiplication, fundamental principle of multiplication. This principle can be extended to any finite number of jobs. Okay, my children, it can be extended to any finite number of jobs or any finite number of events or any finite number of operations as stated below. If there are n jobs or n events or n operations, J1, J2, J3 and so on Jn, such that job Ji can be done independently in mi ways where I is equal to 1, 2, 3, 4 and so on n. Then the total number of ways in which all the jobs can be performed is equal to m1 into m2 into m3 into and so on mn. Okay, my children. In this case, we used fundamental principle of multiplication. I hope you understood the difference between fundamental principle of addition and fundamental principle of multiplication. In the exercise, most of the problems are based on the fundamental principle of multiplication. Okay, my children. But you have to read the question well, understand the question well, and after that you have to apply which is suitable, which fundamental principle is suitable to find the number of ways. Okay, my children. Right. Now come to the exercise 7.1 sums, page number 138. The concept of exercise 7.1 were completed. Only one concept, that is the fundamental principle of counting. Okay, my dear children. Go through the textbook once, go through the textbook. Whatever is given the notes in the textbook before the exercise 7.1, go through the textbook and once go through the examples also, then you can understand well the concept of fundamental principle of counting. Okay, my children. Logical thinking is very important for this chapter. Okay, my children. This fundamental principle of counting is base for this chapter, permutations and combinations. For this chapter, fundamental principle of counting is a base. Okay, my children. So understand well that concept. Okay, my children. Right. Come to the first question in this exercise. How many three-digit numbers can be formed from the digits 1, 2, 3, 4 and 5? Assuming that repetition of digits is allowed and repetition of the digits is not allowed. Two types of questions are given here. What are the digits given here? 1, 2, 3, 4, 5. 5 digits are given in our hand. 5 digits are there. 1, 2, 3, 4, 5. We have to write a 3-digit number. Okay, my children, we have to write 3-digit numbers by using these 5 digits. Okay, my children. So the number of 3-digit numbers is equal to the number of filling 3 blank places, 3 blanks by these 5 digits. Okay, my children. Number of 3-digit numbers is equal to number of 3-digit numbers by using the digits. First repetition, first case, repetition is allowed. Okay, my dear children. Repetition is allowed. We are finding the number of 3-digit numbers. Okay, my dear children. The number of 3-digit numbers by using the digits 1, 2, 3, 4 and 5 is equal to number of ways of filling 3 blanks as shown below by the digits. Okay, my children. So we have to write 3-digit numbers. So let us take 3 blanks. Let us consider this is units place, this is a tens place, and this is a hundreds place. A 3-digit number has 3 places: units place, tens place, and hundreds place. Okay, my children. If you observe, 3-digit number means it must have hundreds place and tens place and also units place. So if you observe this part, there are three events, three operations, three jobs are there. Filling the hundreds place, this is one operation. Filling the tens place, this is the second operation, and filling the units place, that is the third operation. Okay, my children, understood this concept. Filling the hundreds place, this is one event. Filling the tens place, it is a second event, and filling the units place, that is a third event. Here repetition of digits is allowed. In the hundreds place, we can write any one of these three digits, any one of these five digits. In how many ways we can fill this blank five? Isn't it or not, my children? The first job can be done by any one of these five. Okay, my children. So hundreds place is filled. Now come to the second job, second event or second operation. Here also repetition is allowed. So we can use again the same five digits. We can use again these five digits. So second job also can be done in five ways. Understood this point, my children? Now come to the third job or third operation. This also can be done by any one of these five digits because repetition is allowed. So we can use any one of these five digits. So this is the first job, this is second job, and this is the third job. Three jobs must be done, one after the another. Isn't it? No, not my children. After one job is completed, we have done the second job, and after the second job is completed, we have done the third job. So to find the total number of ways, how many ways? 5 into 5, 25, 25 into 5. So we get 125 three-digit numbers. When the repetition is allowed, when the repetition is allowed, when the repetition is allowed, we can write 125 three-digit numbers by using the digits 1, 2, 3, 4, 5. Understood this first part, my children? Right. Now come to the second part of the question. Repetition of the digits is not allowed. In this case, how many three-digit numbers can be written? By using the digits 1, 2, 3, 4 and 5. Okay, my children. See the second part of the question. Repetition of digits is not allowed. Number of three-digit numbers is equal to number of ways of filling the three blanks given below by the digits 1, 2, 3, 4, 5. Okay, my children. Right. Here also three operations. Filling the hundreds place is one event, one operation, one job. Filling the tens place is another job. Filling the units place is the third job. Three different jobs are there. Here, repetition of digits is not allowed. Means if one digit is filled by this blank by any one of the digits, then we should not take that number again. Okay, my children. So see here, three blanks. Suppose let us fill this hundreds place. In how many ways can we fill this hundreds place by these five digits? We can fill this first hundreds place by any one of these five digits. Isn't it or not, my children? So first operation, first event can be done in five ways. Okay, my children. Now come to the tens place. Here one digit is used. One digit is used in the hundreds place. So only four digits are there in our hand. Okay, my children, because here repetition of the digit is not allowed. So if one digit is used here, we should not use that again. So only 4 digits are there in our hand. So the second place, the tens place, can be filled by the remaining 4 digits in 4 ways. Yes or no, my dear children? The tens place can be filled by any one of these 4 digits, because one digit already filled by either by 1 or 2 or 3 or 4 or 5. Then how many digits will be there in our hand? Only 4 digits will be there in our hand to fill the tens place. So this can be filled by any one of the 4 digits. After filling this 4 hundreds tens place, how many digits will be there in our hand? 2 digits are already filled. Only 3 digits will be left. Two digits are over, filled in these two blanks. 3 digits are left. So we can fill the units place by the remaining 3 digits in 3 ways. Isn't it or not, my children? Right. So the first event can be done in 5 ways, second event can be done in 4 ways, and the third event can be done in 3 ways. So you have to perform all these 3 events one after the another. After hundreds place is filled, then second we fill the tens place. This was also completed. Second job is also completed. After the second job is completed, we have done the third job. So therefore, number of 3 digit numbers by using the digits 1, 2, 3, 4 and 5, when the repetition of digits is not allowed, is equal to 5 into 4 into 3. 5 fours 20, 23 60. So we can write only 63 digit numbers by using these 5 digits. We can write 3 digit numbers. How many 3 digit numbers can be written? 63 digit numbers can be written when the repetition of the digit is not allowed. Okay, my dear children, understood? Right. Now come to the next question, question number 2. How many 3 digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? Understood this question, my dear children? Right. We have to write 3 digit even numbers. Even numbers should be formed, 3 digit even numbers, by using these 6 digits. Okay, my dear children? So come to the solution part. What are the digits given to us? 1, 2, 3, 4, 5 and 6. Out of these 6 digits, what are the even digits? 2, 4 and 6. Yes or no, my dear children? Yes. Now you have to remember what is meant by even number. In the even number, units place should be even digit. Yes or no, my dear children? Isn't it or not? Yes. Even digit means in the even number. Even number means in the units place even digit should be there. What are the even digits here? 2, 4, 6. Okay, my dear children. Right. So 3 digit even numbers. 3 digit even numbers. 3 digit even numbers is equal to number of 3 digit even numbers. Number of 3 digit even numbers. Number of 3 digit even numbers is equal to number of ways of filling the three blanks given below. Okay, my children. Right. Let us take three blanks. Three blanks. But this three-digit number should be even number. Okay, my children. So there are three events. Three jobs are there. Filling the hundreds place, filling the tens place, filling the units place. These three jobs. Okay, my children. We have to perform all these three jobs after the other. After one job is completed, we have to perform the another job. After the second job is also completed, we have to perform the third job. Okay, my children. Here, first of all, we have to concentrate on units place because even number. Even number means in the units place, even digit should be there. Yes or no, my children? Yes. So what are the even digits in the given digits? 2, 4, 6. So the units place can be filled by any one of these three digits. Yes or no, my children? Either by 2 or we can fill this units place by 4 or you can fill this units place by 6. So three ways. Understood this three number, my children? Right. Now come to the tens place. Here repetition is allowed, can be repeated. So any number can be repeated. So this tens place can be filled by any one of these six digits. Okay, my children, this 100 tens place can be filled by any one of these six digits. Similarly, hundreds place, this job is completed. Second job. This is the first job. Filling the units place is the first job. We performed this job in three ways. After this first job is completed, we have completed second job. This can be done in six ways. Now come to the hundreds place. This is also can be filled by any one of these six digits because repetition is allowed. Okay, my children, we have to keep this point also in your mind. So the third job also can be filled. The third event, the third operation also can be done in six ways. Okay, my children, understood? So we have to perform all these three jobs, one after the other. Therefore, by the fundamental principle of counting, short form, the number of three digit even numbers, three digit even numbers by using the digits, 1 2 3 4 5 and 6. When the digits can be repeated, is equal to, how do you find 5? By the fundamental principle of counting. Which fundamental principle of counting can be used? Principle of addition or principle of multiplication? Yes, principle of multiplication, because we have to perform all these three jobs one after the another. Okay, my children. So 6 into 3. 6 are 36. 36 into 3. So 108. 108 three digit even numbers can be written. Three digit even numbers can be written by using the digits 1 2 3 4 5 6, and the digits can be repeated. Understood this point, my children? Right.